Derivation of Formula 4. Cos of A minus B equals cos A cos B plus sin A sin B. Let P and Q be 2 points on the unit circle. Here, our radius is 1. Labelling angle B and angle A. This gives us the triangle with sides 1, 1, angle A minus B. Using the cosine rule, PQ squared equals 1 squared plus 1 squared minus 2 times 1 cos of your angle, which is the angle A minus the angle B. This gives us PQ squared equals 2 minus 2 cos A minus B. This gives us one formula for the distance PQ. Using the distance formula, we find the distance PQ is equal to the square root of cos A minus cos B squared plus sin A minus sin B squared. PQ squared equals cos A minus cos B squared plus sin A minus sin B squared, which gives us PQ squared equals cos squared A minus 2 cos A cos B plus cos squared B plus sin squared A minus 2 sin A sin B plus sin squared A. Simplifying this gives us cos squared A plus sin squared A plus cos squared B plus sin squared A minus 2 cos A cos B minus 2 sin A sin B. PQ squared equals 1 plus 1 minus 2 cos A cos B minus 2 sin A sin B. This gives us PQ squared equals 2 minus 2 cos A cos B minus 2 sin A sin B. We now have two formulae for PQ squared, and we can equate these. This gives us 2 minus 2 cos A minus B equals 2 minus 2 cos A cos B minus 2 sin A sin B. Cancelling out our terms on both sides and dividing by minus 2 gives us cos of A minus B equals cos A cos B minus 2 sin A sin B. Formula 5. Cos A plus B equals cos A cos B minus sin A sin B. Our proof. We use the same proof as Formula 4. Then we replace B with minus B on both sides. This gives us cos of A minus B equals cos A cos minus B minus sin A sin minus B. As cos minus B equals cos B and sin of minus B equals minus sin B, we can state that cos A plus B equals cos A cos B minus sin A sin B. Let's look at Formula 6. Cos of 2A equals cos squared A minus sin squared A. Our proof. We know that cos A plus B equals cos A cos B minus sin A sin B. This gives us cos of A plus A equals cos A minus sin A sin B. And so cos 2A equals cos squared A minus sin squared A. Formula 7. Sin A plus B equals sin A cos A plus cos A sin B. We're given cos of A minus B equals cos A cos B plus sin A sin B. Here we replace A with pi over 2 minus a on both sides, which gives the following. Cos times pi over 2 minus a minus b equals cos pi over 2 minus a cos b minus sine pi over 2 minus a sine b. But cos of pi over 2 minus a equals sine of a. You do not need to prove this. And also sine of pi over 2 minus a equals cos a. And therefore cos of pi over 2 minus a minus b equals sine a cos b minus cos a sine b. And cos of pi over 2 minus a plus b equals cos sine a cos b minus cos a sine b. And so sine of a plus b equals sine a cos b plus cos a sine b. Formula 9. Prove that tan a plus b equals tan a plus tan b all over 1 minus tan a tan b. We're given that tan a equals sine a over cos a. Therefore, tan a plus b equals sine a plus b over cos a plus b. And so tan a plus b equals sine a cos b plus cos a sine b over cos a cos b minus sine a sine b. Divide the above and below by cos a cos b. And cancel out our cos b terms and cos a terms. We're left with tan of a plus b equals sine a over cos a plus sine b over cos b all over 1 minus sine a sine b over cos a cos b. And therefore tan of a plus b equals tan a plus tan b over 1 minus tan a tan b. Please pause the video and take down this proof.